Hey guys, Miss Subin here, and today we're going to be talking about comparing and ordering rational and irrational numbers, but on a number line this time. So again, we'll compare several real numbers and place them on a number line in the correct order. So we talked about this on the last class, that we can compare these numbers, if they're all written the same way. And right now we have a decimal for 4.8, a fraction of 20 over 4, and a imperfect square root, which is the square root of 22. Right now these are hard to compare because they're all formatted differently. So we're going to format them all the same and turn them into a decimal to make them easier to compare and easier to place on a number line. So we're going to use a number line to compare more than two real numbers. The nice thing about a number line is that it will put them in order from least to greatest as we do the problem. So we're going to be creating our own number lines, so we're going to check our work every time to ensure that we are correct. All right, so let's look at a problem together. We're going to compare these real numbers using a number line. So right now, they're not in the same format, so we're going to convert them all into a decimal so they're easier to compare. So first, I see the square root of 31. Now, the square root of 31 is not a perfect square, so I'm going to have to use my square model in order to estimate this. So the perfect square that's closest to 31 without going over would be 25. So 1, 2, 3, 4. 1, 2, 3, 4, 5. So here's a 5 by 5 that equals 25. Now we're going to want to make this one row taller and one row wider. 5 is going to be our whole number. The red boxes, I have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Starting at 25, let's count to 31, and I'm going through this quickly because you should already know how to estimate here. So 25, 26, 27, 28, 29, 30, 31. We use 1, 2, 3, 4, 5, 6 out of our 11 boxes. We can write this as a decimal by keeping our whole number 5 and then doing 6 divided by 11, which my calculator gives me 0.545454 forever, but we're going to estimate just by writing the first number after the decimal whenever we do a square root. So 5.5. It's around there. Let's convert all of our numbers before we start graphing on our number line. 23 over 4, I can calculate by putting in my calculator 23 divided by 4, which is 5.75. Now all of our values, well, 5.1 is already a decimal, so we don't have to do anything there. All of our values are 5 point something, so that means that all of our answers are going to be graphed somewhere between 5 and 6. Now that's not enough for us because we could just put these randomly on the number line, but we want to be a little bit more specific. So I'm going to label in between here, starting with 5.5. 5.5 is directly in the middle of 5 and 6. 5.5 is 5.5. Then I'm going to put on here 5.2, 5.3, 5.4, then we have 5.5, 5.6, 5.7, 5.8, and 5.9. Now that we've labeled our number line with all the tenths between 5 and 6, I'm going to start to actually label my values that we came up with here. So 5.5 is right here. I'm going to put a point. and I'm going to label it with what was originally my problem, which was the square root of 31. 5.75 is a little bit bigger than 5.7. So I'm going to go a little bit bigger than 5.7. But I'm going to label it with the fraction we used to find that value. And then finally, 5.1 is exactly 5.1. So I'm going to label it 5.1. If you need more time with this problem, you can pause it here. Otherwise, you can move on to the next one. If you need that last problem, sorry I cut myself off, you can go back and pause, but we were done with the problem, so we're going to move on to this example. So right now I see fractions, decimals, and square roots that we're all putting on the same number line. To make this a little bit easier, we should put them all in the same format, and the way that's easiest is putting them all as a decimal. So I'm going to go ahead and start with 19 over 25. 19 over 25 I can put in my calculator by doing 19 divided by 25, and I'm going to write exactly what I get, which is 0.76. 0.33 is already a decimal, so we don't have to do anything with that one. And 0.68 is already a decimal, so we don't have to do anything with that one either. Square root of 1 is actually one of our perfect squares. 1 times 1 equals exactly 1, so we don't have to draw a model for this one. I can just write that the square root of 1 is equal to 1, because 1 times 1 equals 1. Then finally, 2/3 is a fraction, so I'm going to use division to find the value. Numerator divided by denominator, 2 divided by 3 in my calculator. I'm going to get 0.666666 forever, so I'm going to use 0.6 repeating as our value here. And we're going to write the exact value because we know how to get the exact value. We're not going to estimate here. All right, so for my number line, I want to make sure I'm zoomed in just enough that I can fit all my numbers but be able to see them very clearly. So if I were to mark this from 1, sorry, I'm thinking ahead of myself. If I were to mark this from 1 to 10, that would be too far spread out. So instead, because look at my values before I say why that's not a good idea. My values, the smallest value we have is 0.33, and the largest value we have is 0.76. All of these numbers are between 0 and 1. So I'm actually going to label my number line accordingly. Since all my values are between 0 and 1, I'm going to start at 0 and end at 1. Now we're really zoomed in here, so we should mark some things in the middle. The very middle is 0.5. I'm actually going to go ahead and mark all of my tenths places. So I'm going to put 0.1, 0.2, 0.3, 0.4, 0.5 stays in the middle, 0.6, 0.7, 0.8, 0.9. Now it's up to you how much you want to label these, but I knew that I needed more than just the beginning and end to be able to graph these accurately. So I decided to break it into 10 parts because it's easy to break a number into 10 parts if you label it by its tenths place. Because if you look at the numbers I used, I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then a whole number 1. They're just all tenths places, so they're after the decimal. Let's start to place our numbers on our number line. Let's start with 0.76. 0.76 is a little bit more than 0.7 because it starts with 0.7 and has something after. So 0.76 is actually going to be between 0.7 and 0.8. I'm going to place it right here with a dot, and then I'm going to label it with the original value given to me in the problem, 19 over 25. We use the 0.76 to locate it on the number line, but we still label using the original problem. Then we have 0.33. 0.33 I would place in between 0.3 and 0.4. So again, I'm going to mark it with a dot. Then I'm going to place 0.33. So that's the second one done. 0.68 is a little bit more than 0.6. So I'm going to put that, let me make a dot. And I'm going to label it with what it was originally called, 0.68. The square root of 1 is equal to exactly 1, so that's how I'm going to label it on my number line. I'm going to label it square root of 1 because that's what's originally told me in the problem. Now this last little bit is the hardest part here. We have 0.6 repeating, which is 0.66666 forever, which will go between 0.6 and 0.7. But we already have a number between 0.6 and 0.7, so we need to make sure that we put it on the correct side of the 0.68. So I'm looking at 0.68 compared to 0.66. They both start with 0.6, so they're both going to go in between 0.6 and 0.7. But 0.68 is a little bit bigger than 0.66 because 68 is bigger than 66. So I'm going to place 0.66 just a little bit below 0.68. Just make sure that you label this with the fraction they gave you, 2/3. So it's hard to read, thirds. If you need more time copying this, you can pause here, but I'm going to move on. So we're going to try another example. On this slide, you can see that we have some fractions, some decimals, and some square roots. So first thing we need to do in order to truly be able to compare these, we're going to change all of them into decimals. So using your calculator, we're going to do 64 divided by 16. And our calculator, it actually tells us that gives us our whole number 4. So we can think of 64 divided by 16 as being 4. We place it on a number line. 3.63 is already a decimal. We do not have to do anything with that one. Then we have 25 over 8. Again, I'll use my calculator to do 25 divided by 8. And that's going to equal 3.125. And I'm going to write it in its entirety so that way I have all the information in places on my number line. The square root of 9 is one of our perfect squares because 3 times 3 equals 9. The square root of 9 is actually going to be exactly 3. And then finally, I have my square root of 12. This one's not a perfect square, so we're going to have to estimate here. So I'm going to draw the closest perfect square without going over, which would be 9 for the square root of 12. I'm going to start with a 3 by 3 square, which is 9. Then I'm going to make it 1 box taller, 1 box wider, and 3 is my whole number. We have 1, 2, 3, 4, 5, 6, 7 new boxes to use. And we have 9, 10, 11, 12. We need 3 out of those 7 boxes. 3 is my whole number. Then in my calculator, I'm going to do 3 divided by 7. And that gives me a 4 after the decimal. Since we can only estimate a non-perfect square under a square root, we're going to stop there. We're not going to write everything after the decimal. So 3.4 is the about value of square root of 12. Looking at all of my answers, my biggest value was 4, and my smallest value was 3. So I'm actually going to go between 3 and 4 here. I'm going to label the middle as 0.5. And just to be a little bit more specific, because we only have the 2 numbers to really work with, I'm going to label each tenth. So 3.1, oh, whoops, I did something wrong. This is not 0.5. 0.5 is not in the middle. It should be 3.5. The middle of 3 and 4 is 3.5. Sorry about that. So 3.1, then 3.2, then 3.3, then 3.4, 3.5 in the middle, 3.6, 3.7, 3.8, 3.9. Now that we have our number line labeled, we're going to go ahead and put our values on there. Starting here, we have 4 is the value of 16 over 4, or 64 over 16. So I'm going to take my mouse and I'm going to put a point exactly on 4, but I'm going to label it 64 over 16. Right, first one's done. 3.63 is a little bit more than 3.6. So I'm going to put a point a little bit bigger than 3.6. And I'm going to label it 3.63. So we're done with that one. Next we have 3.125. That's going to be a little bit bigger than 3.1. So I'm going to put a point a little bit bigger than 3.1. And I'm going to label that with the original fraction 25 over 8. Next value we have is the square root of 9, which equals 3. So I'm going to put that point exactly on 3. And I'm going to label that square root of 9. I'm going to label that square root of 9. And then finally, the square root of 12 was 3.4 just about. So we're going to put our point on 3.4, but we're going to label it the square root of 12. Now we have our 5 points on our number line.